As promised, my section is going to be on light and the visible light part of the spectrum. So the first thing that we're going to do is review the essential standards. The essential standards for this section are going to be 6.P.1, which is understanding the properties of waves and the wave-like properties of energy. And earthquakes, so we're going to talk a little bit about earthquakes and those natural disasters and how it affects things in our lives. And light and sound waves. And so we're going to talk about how sound waves are produced, how they move through medium, and how it is that we hear those sound waves. Okay, so let's look at the objective. The objective for this section is going to be 6.P.1.2, which is explain the relationship between visible light, the electromagnetic spectrum, and sight. So we're going to talk about how we see the colors of the visible light. So you're going to find out that visible light is the reason we see colors, and how we see those colors. We're going to look at the essential questions, which are really important for you guys. So by the end of this lesson, you should be able to answer these questions, which is what part of the electromagnetic spectrum is visible light. So we're going to look at where we can find visible light on the electromagnetic spectrum, so you're going to be very familiar with the electromagnetic spectrum. And what causes light to appear as different colors. So why do we see red? Why do we see white? Why do you see black? Why do you see those colors? So we're going to take a look at those things. So the first thing we need to do is define what light is. And what you're going to find out is that light is actually a wave. And waves are nothing but disturbances or vibrations that carry energy from one place to another. So we're going to look at why waves, or how waves move, why waves move the way they do, and what type of waves move through different mediums. So you're going to look at waves as being a disturbance or a vibration. So anytime you hear something vibrate, or you see something move through something else, some type of medium, some type of solid, liquid, or gas, that's a wave, okay? And you're going to find out what waves move through solids, liquids, and gases, and what waves move through no medium, which means they don't move through a solid, liquid, or a gas. So let's look at light waves in general. Light is nothing more than photon energy. A photon is, or photons are those things that have no mass. They move through medium, but they don't have to, and they can pass through a vacuum. So let's think of what a vacuum is, because I'm pretty sure you just think of a vacuum as something that you suck up dirt with on your floor. But let's say you are in the room that you're in, and Miss Strother sucked all the air out of that room. Essentially, you wouldn't be able to live in that room because you couldn't breathe. But light waves would be able to travel through that room because you're traveling through a room with no medium. The medium in the room at the time is air. So light can travel through what we call a vacuum. Light is a part of the electromagnetic spectrum, so it is an electromagnetic wave. And it's in the spectrum in the area between infrared and ultraviolet. So on your project, I asked you to identify where certain waves were. Visible light is going to be identified on the spectrum in between the infrared and ultraviolet section of the spectrum. Electromagnetic waves are going to be those waves that move through electromagnetic fields. We're going to talk a little bit more about electromagnetic fields in class. But electromagnetic fields are those things that do not require a medium. So electromagnetic fields are what hold the earth in place. It holds the sun in place. It holds our solar system in place. Those electromagnetic waves that are on the spectrum, they do not require a medium. Transverse waves are going to be waves that we learn about later in transverse waves are going to be those that require a medium. So we're going to look at those different types of electromagnetic waves. And transverse waves, again, are going to be those waves that require a medium. So electromagnetic waves do not require a medium, but transverse waves do. And when we get to sound waves, we'll start to talk about those waves that require a medium. So when we look at the electromagnetic spectrum, it's divided into 7 different types of electromagnetic radiation. Radio waves are going to be the weakest type of waves, and it's going to move from radio waves to gamma rays. So radio waves are going to be the weakest, gamma rays are going to be the strongest. So second to radio waves and being stronger, going to be microwaves. Then infrared, it's going to be a little bit stronger. Visible light's going to be a little bit stronger. Ultraviolet, stronger. X-rays, very strong. And then those gamma rays are going to be the strongest. So let's look at the spectrum. The spectrum looks like this, okay? And the spectrum shows us a couple of things. One of the things the spectrum shows us is the wavelength. The wavelength is going to be the distance from what we call a crest to a crest, which is the top part of the wave, or the trough to the trough, which is, those are 2 of your vocabulary words. So the distance from here to here, or let's look here to here, is going to be a wavelength, or you can measure it from here to here, which is a wavelength as well. So from crest to crest or trough to trough. Okay, and the shorter the wavelength gets, okay, so you see how the distance between the waves gets shorter as you move towards gamma rays, the more dangerous these waves become. So our radio waves are essentially very weak with a long wavelength. Our gamma rays are going to be very, very short with a strong strength. Okay, so let's look at the visible part of the spectrum. If you notice, the visible part of the spectrum is divided up in colors. We're going to take a look at those colors in just a second. Okay, so let's look at the different colors of the spectrum. An easy way to remember the colors of the spectrum from lowest to highest frequency, which is from a longer wavelength to a shorter wavelength. So frequency is the number of waves that pass a certain point at a time, and we'll go back to that in just a second. That's frequency. So Roy G. Biv. So R in Roy stands for red, O for orange, Y for yellow, G for green, B for blue, I for a color we call indigo, and V for violet. So this is a really easy way for you guys to remember. So let's talk a little bit about frequency. Frequency is basically the number of waves that pass a certain point at a time, okay? So if a lot of waves pass, your frequency would be high. If a lower number of waves pass, then the frequency would be low. So let's identify what a wave is. A wave is going to be a full crest and a full trough. That's identified as a wave. So a full crest, a full trough. If I have that pass, that's my frequency. Okay, so the lower my frequency, the longer my wavelength. So if my wavelength is long, the lesser number of waves will pass that fixed point. So the longer my wavelength, the lower my frequency. Down here you notice that the wavelength is short. So the shorter my wavelength, the higher my frequency, because more waves are passing that fixed point. Okay, so let's summarize. The longer my wavelength, the lower my frequency. The shorter my wavelength, the higher my frequency.